Welcome to E. Podasala lecture series in computer science. In this module, we are going to discuss of how to write basic algorithms. Remember last module, we concentrated on some of the basic terminologies of algorithms. So, the objectives of today's module is going to discuss some basic notations about algorithms. I am also going to tell you how to design an algorithms, and as part of this module we are going to discuss about how to write certain elementary algorithms in iterative as well as in recursive way. Remember last module we discussed about the basics of algorithms. As you can recollect, the algorithm is nothing but a step by step procedure or instructions to be followed to solve a given problem. So, I was telling you that algorithm can be compared with the blueprint of a building. So, algorithm tells how to solve a given problem. You can also know that there are many ways of solving a problem. If a problem is given to a class of 30 students can come up with different sorts of algorithms. All are correct provided if it gives the expected results. So, the algorithms are not a standardized way. So, there is a necessity to put some concrete principles, so that we can conceptualize the way of how the algorithms should be written. Though the solutions are different, the methodology that we are going to follow should be such that there is some sort of a uniform way of expressing the algorithms. Fine. How to design an algorithms? So, this is where the design is coming into picture. So, for initial period we will start with a design paradigm called stepwise refinement. What is stepwise refinement? The stepwise refinement is something like this. So, given a problem, we try to decompose that problem into many sub problems. Again, the sub problems can be divided into many other sub problems. Like that, we keep on decomposing the problem till we get a scenario where we cannot further decompose that particular sub problems. So, when we reach that particular situations, we have lots of structures or sub problems that can be coded into some sort of a control structures. What are control structures? Control structures are the heart of any program or algorithms, and there are three structures we have. One is called sequence, next is called decision, and third is called repetition. What is a sequence? Sequence is a control structure that allows the sequence of elements to be executed sequentially. For example, the given code here, like perform task P, task Q, task R, represents the sequential control structures. So, in any algorithms we will have sequence structures where we need to execute some set of statements. The second control structure is called decision. Decision or conditional branching is a conditional or control structure that executes the condition first, and based on the results of the condition results, the tasks are carried out. A sample decision structure is given here. You can observe that it starts with condition C. First condition C is getting executed. It is a expression. So, it has got two results, true or false. If the condition is true, then task A is getting executed, otherwise the task B is executed. This kind of structure is what we are calling as decision or conditional branching. Third structure is called repetition. Repetition is another control structure that is used to represent for performing tasks in a repetitive manner. This is an example of a repetitive structure where we can see that the condition C is getting executed first, then based on the truthness the task or is repeatedly performed. Once we have these sort of control structures, then we have to put all these control structure into a algorithm. So, for this reason we have three choices. This way of representing the algorithm is called algorithm specifications. There are three ways in which the algorithm can be specified. Number one is we can use natural language. By natural language we mean that the languages like English or any other natural languages to explain how the task has to be carried out. This has got certain advantages. For example, the third person can understand what the algorithm is all about, but the problem is the words are ambiguous. Therefore, the algorithm will not be a some sort of confusion or ambiguity will be there as part of the algorithms. Because of these reasons, natural languages are not preferred. Programming languages can also be used to specify the algorithms, but the disadvantage of this approach is that the algorithm will be biased towards a particular language. Therefore, if a person do not know the programming language, then he may have trouble in interpreting the algorithms. Therefore, the natural choice for writing algorithm comes to a pseudocode. Pseudocode is a mixture of natural and mathematical language which tries to combine the advantages of both the approaches. The advantages of pseudocode are that it is very easy to understand and it is also independent of any programming language. Therefore, it has become a very standard practice to write algorithms in a pseudocode. Fine. Suppose if I know how to execute a particular way of getting the solutions, then how do I write instructions in pseudocode? There are no general guidelines of how the pseudocode should be written. There are many ways of writing that, but for the general sake we can try to put some sort of a guidelines so that the algorithm writing can be generalized. In any algorithms we will encounter assignment statement. So, let us try to evolve some sort of a guidelines for algorithm writing. So, these are some of the examples of assignment statement. For example, I am assigning the constant 20 to the variable x and I am executing condition r plus k equal to z. Similarly, in algorithms we will encounter many situations where we have to read some values from the keyboard and many times we may have to write the values on the screen. So, we will try to design two statements, input statement which is used to give values to the variables of the algorithm. An example of input statement is input x comma y. Similarly, we can say that output statement is used to write or print the values of the variables. One example we can say is print x comma y or write x comma y. So, to implement the branching we require some sort of a statement. We will use a statement called if then statement. So, the syntax is like this: if condition. So, if the condition is true, then execute a single statement or a block of statements. So, end if is just a keyword that we are trying to put to mark the scope of the statement. So, this is a better way of writing the algorithm so that we can know exactly where the algorithm ends. We can use if then else statement also as a branching structure. So, the syntax is like this: if, then you have a condition, If the condition is true, then the statement A is getting executed, otherwise the statement B is getting executed. Then we have repetitive control structure. For that we require some sort of statements. So, for statement is a very popular statement to implement repetitions. The syntax is like this: for variable equal to value 1 to value 2 do. That means, initially value 1 is assigned to the variable, the statement is getting executed, the default increment is 1, then the variable is incremented. When the variable becomes equal to the value 2, we are coming out of this particular loop. So, we can also increase the step size, that is, instead of 1 we can increment by any other value, and as part of this loop there can be one or many statements. The repetitive control structures can be implemented by means of the while condition also. So, the syntax is like this: you have while, you have condition. If the condition is true, then we start executing a statement or a group of statements. When the condition becomes false, then we are coming out of this particular loop. Similarly, the repetition can be done by means of the repeat statement also. The syntax is like this: repeat, then we are executing a single or multiple statements, and this is getting executed until the condition becomes false. In other words, these are some of the ways of writing the algorithms. So, once we have these statements ready, we can start practicing writing some simple algorithms. So, as part of this module, let me take one simple example of conversion of Fahrenheit to Celsius. So, the given problem is we have to write an algorithm to convert the given Fahrenheit temperature to Celsius. Fine. How to do that? Fine. The answer is in terms of this particular formula. We have the formula Celsius is equal to 5 by 9 multiplied by what you say f minus 32. Fine. So, now as I said earlier, algorithm is nothing but a step by step procedure for carrying out this particular task. Suppose if I give this problem to a student, so how you would start? Fine. His way of thinking will be something like this. Fine. I am going to read the Fahrenheit, then I know the formula of converting that to Celsius. Therefore, I will apply this particular formula to compute the equivalent Celsius, and once I compute that, then I am going to print this particular value. This is what his way of thinking is going to be. So, we can put this kind of thinking exactly as a step by step procedure. So, the informal algorithm can be written something like this. Fine, there is no standard way of writing the algorithms. If I give this task to different people will write the algorithm in a different manner. So, one way of writing this algorithm informally will be something like this. Fine, step 1. So, this is an informal algorithm. I am going to ask the user to enter a Fahrenheit temperature, then I am going to compute the equivalent Celsius temperature using this particular formula. Third thing is I am going to display the results. Fine. Now, instead of asking the temperature, we can write algorithm as a function where the main algorithm can pass the value directly to the functions. Like that also I can do that. So, if I do that, fine, my formal algorithm is going to be like this. So, we can see this is how a basic algorithm looks like. You can see I am saying algorithm, then I am putting a name for this particular algorithm, that is F2C. So, I am getting a parameter. So, that parameter is going to be in terms of Fahrenheit, and I am going to compute the equivalent Celsius, therefore, the output is going to be a Celsius temperature. Begin and end are keywords which tells where the algorithm starts and where the algorithm ends. So, as part of this segment, you can see very well I am computing the Celsius using this particular formula, and once I compute that, I am going to return this Celsius value to the main algorithms. So, in short, this is how a simple algorithm will look like. Fine. So, having understood this, now we will move on to the next problem. So, next problem is going to be finding the sum of odd and even numbers of an array. Fine. Let us assume that you are given a array consists of n numbers. The numbers can be odd or even. So, the problem is you have to find the sum of odd and even numbers, and also you have to find the number of odd or even numbers that are present. Fine. So, this is the formal algorithms. You can see exactly how it goes. So, I am writing algorithm, I am giving a name. So, the parameter for this algorithm is array. So, array A 1 to n, and the output of this algorithm is going to be the sum of odd and even. Also, I am going to give the count of some or odd numbers. So, begin. So, I am going to initialize all the variables like odd, even count, odd sum, even sum, etc. So, now I am going to read from array one by one, and I am going to check whether the number is odd or even. Fine. So, you know the logic of how to find the odd or even number. So, you can do modulus mod 2, and if the remainder is going to be 0, then we can say that it is a even number. So, you can see exactly what is happening. I am starting a loop I 1 to n, then I am reading the number, I am taking the remainder. If the remainder is going to be 0, then I am concluding that this is a even number. Therefore, I am taking the sum of the old one plus the existing number, and also I am incrementing the count by 1. So, when all n numbers are processed, find all the results, all the values are going to be there in the form of even sum, even count, odd sum and odd count. So, I am going to return all these values as part of these algorithms. So, this is how the algorithm for this particular problem looks like. We will take one more problem. We will see how to write algorithm for this. So, I am taking a simple problem called linear search. So, here you are given a array, and the array consists of n numbers. You are also given a target number or target value. You have to check whether the target value is present in this array or not. If it is present, then we have to print the index where the target is present. Otherwise, we have to print that the target is not present in this particular array. Fine. So, this is how informally the algorithm will go like. Suppose if I give this task to a student, how he will proceed? He will take the target value, he will take the first element of the array, he will check whether the first element is equal to target. If so, he will print that the target is present. Otherwise, he will go to the second element of the array. Then he will go to the third element, and this process will be continued till all the elements of the list are processed. So, this is what given here informally as follows. So, getting the value of the target, then we are reading the list of n values. So, initially I am setting index equal to 1, so that I am going to start the search process from array 1. Then initially I am setting the variable found equal to false. So, now I am starting a loop, repeat until true, then index is greater than n. So, that means I have to repeat until these conditions are fulfilled. So, under this condition I am going to test the target with all the elements of the array, and if the element is equal, then I am outputting the index, and also I am setting the condition as true for the variable found. Otherwise, I am just incrementing the index. So, you can see exactly this is converted into a formal algorithm like this. So, you can check the formal algorithm now. So, formal algorithm says algorithm, then algorithm name I am putting as search, the input parameters are list of n elements and also the target. So, begin and end are the keywords. So, under which I am setting index equal to 1, then initially I am setting found equal to false, then I am starting the condition, and I am all checking the target with all the list elements, and I keep on doing that till my item target is present or not. So, this is how the formal algorithm looks like. So, now you can come to a conclusion of how to write some basic algorithms. First, you have to take a problem, then you have to use a stepwise refinement, and if you do that, you will have some set of control structures, and once you have the control structures, you have the basic guidelines, so of how to use the statements, and using these statements you can write algorithm both informally as well as formally. Style is important because this algorithm should be able to be easily understood by the third persons. Because of this particular reason only, we are giving lot of importance for algorithm writing. Fine. So, once we know how to write iterative algorithms, we can start thinking about recursive algorithms. In computer science, we may have to write recursive algorithm many times. So, what is a recursive algorithm? A recursive algorithm is an algorithm that uses recursive functions. What is a recursive function? A recursive function is a function that calls itself. So, in other words, recursive functions use the concept of self-reference. So, the kind of definition using self-reference is what we are calling as recursive definition. Using these recursive definitions, recursive functions are written. Any algorithm that use recursive function to implement is what we are calling as recursive algorithms. Fine. In any recursive algorithm, these three steps should be present. Number one is base case. Base case is nothing but the initial value. So, this is where we have to initialize the variables. Then you have recursive step. This is the recursive part of the algorithms. So, this calls conditionally itself. So, the value of the function is computed in terms of the previous values of the functions, and finally, you have some sort of a progress towards the base case. So, this is required to ensure that the algorithm actually converges. So, you might have encountered recursive algorithm in many ways. For example, factorial of a number is a recursive function. You all know that n factorial is equal to n into n minus 1 factorials. So, in the same manner, the recursive functions can be written. We will take one example of how to write recursive algorithms. Let us take the problem of summation of an array using recursions. So, the recursive definition is something like this. So, sum of n is going to be 0. if n equal to 0. This is a base condition. That means if there are no elements, sum is going to be 0. And once I define the base conditions, then I can define the recursive part. What is the recursive part? Sum of n is nothing but n plus sum of n minus 1. In other words, it is nothing but n plus the sum of all other n minus 1 elements. This sort of function is what we are calling as the recursive function. Once the recursive function is defined, fine, I can write recursive algorithm like this. So, you can see exactly the pattern of writing the recursive algorithm is very similar to iterative algorithms. Algorithm sigma n. So, n is going to be the input parameter. So, the output of this algorithm is going to compute the sum of n numbers. If n is going to be 0, according to the recursive function, we are going to return the value of 0. Otherwise, we are going to return the value of n plus sigma of n minus 1. So, this is how the recursive algorithm looks like. Fine. You can ask a question like this: why can't we write in an iterative manner? Fine. We can also write an iterative algorithm for this, and the iterative algorithm is going to be like this. So, you can see exactly the input output problem statement exactly are similar, but in the body we write sum equal to 0, then we are starting a loop for I equal to 1 to n. Under that circumstances, we are saying that sum equal to sum plus I. So, this is what the iterative sum is all about. Fine. This leads us to a question, which is the better way of writing the algorithms. Fine. There are both advantages as well as disadvantages. Recursive algorithms are very compact, very ideal way of writing the algorithms. It is a gift for the programmer, but it is also a bane for the compilers, etc., etc. If the conditions are not properly defined, then the recursive algorithm will loop in an infinite manner and the algorithm may not terminate at all. So, some sort of a cautious approach should be taken by the student to decide which is the best way of writing the algorithm for the given problems. So, this is the factorial problem. So, you can see very well how n factorial is equal to n into n minus 1 factorial is implemented as a form of algorithms. So, you can see very well it takes the value of m. If m is less than 0, then factorial of negative number is not possible. If it is 0 or 1, factorial is going to be 1, otherwise it is going to be what you say m into m minus 1. So, that means I am using the variable m instead of n as part of these algorithms. And towers of Hanoi is also one of the most frequently used algorithms. So, this is called the towers of Hanoi. So, you know very well there are 3 pegs. You have n disk. The problem of towers of Hanoi is you have to transfer the disk from peg A to peg C using peg B as the intermediate peg. So, you can see very well the towers of Hanoi works on these rules. That means, at any one particular point only one disk should be moved, and at no point of time a larger disk can be placed on a smaller disk. So, we can think recursively for solving this problem as something like fine. So, move all n minus 1 disk to the intermediate disk, then move the larger disk to the target C, and then you start thinking about how to move n minus 1 disk from the intermediate one to the target. So, this is how the algorithms looks like. So, you can see exactly why recursive algorithms are chosen for this. It is very compact. If n equal to 1, that means only one disk, you can move the disk directly from A to C. Otherwise, you are moving n minus 1 disk to B using B as the temporary one. Then we are moving the larger disk from A to C, and all the n minus 1 disk from the intermediate is transferred to your target. In short, we can come to a conclusion that writing algorithm is a great skill that needs to be mastered by every student. So, there is no general way of writing an algorithm. So, we can write some sort of a guidelines of how to write algorithms. So, we can apply the stepwise refinement, we can evolve control structures, and after that we can start writing algorithms both informally as well as formally. So, with this this module is coming to an end, and next module we will just discuss about how to analyze these algorithms. Thank you very much.